Hey guys, welcome back to another RSK coding video, and in this video I'm basically going to be starting a new series where I'm doing something which I've never actually tried before, but basically I wanted to continue this neural network series and I wanted to go on a project. So basically we're going to be doing a project where we try and train a neural network to do arithmetic. So that's like adding, subtracting, multiplying, dividing numbers, and like I know this is quite useless is the word, because like computers are already like super good at arithmetic, but I thought it would be a fun challenge. I don't even know if it's going to be possible, but yeah. So basically we want to feeding a arithmetic task like let's just say 1 plus 1, and you want to get the computer's output, and we're basically going to be training a neural network to do that. So yeah, hopefully it allows us to learn a bit more about neural networks. In the previous parts of this series, I've actually just talked about building a neural network from scratch. So yeah, but I don't think I've introduced the backpropagation algorithm, so you know, I might make a video on that in the future, but for now I'm just going to be using this library which I created. It's basically similar to what I've shown you guys how to make so far, but yeah, so we're just going to be using this because this is implemented backpropagation, and yeah. Also, we might be able to, in the far future, start introducing GPU to make our things faster, to make our neural network faster. So, first of all, I'm just going to create the project, and then I'll go over the basics of how this thing might work. So, let's use the npm create vanilla template. Let's just create that, and then let's just import the neural network as shown. So, I'm going to be working in TypeScript for this. Pretty much the whole thing, just because it's a lot easier. Let's just call this neural network, and we will just add in all these files which you see over here. So just add this and ignore the errors for now. Network.ts. Oh, I was typing in the wrong place. Network.ts, and we'll just add this in here. And yeah, this is basically just how you import the thing, my neural network library. So persistence, and I think I spelled persistence wrong. Not sure though, so I'll just follow how it's spelled here. Persistence.ts, and let's just put all of this in here. Okay, now final step before we actually get onto looking at the overview, I just got to create a script.ts that's already there, so we can just add in this. Just add in neural network. I think that's how you do it. It's alright, we'll find out later. Okay, so there's the setup complete. Now I can talk about the overview. So let's bring out Clicky Paint tool. So what I'm thinking is our inputs are going to be something like let's say input, and our inputs are going to be something like 1 plus 2 or 1 plus 3, and we're not going to put the equal sign, but we basically want the neural network to output this. Obviously this is simple arithmetic, and you know, we can have all operators, so we could even have like something like 3 times 7, and it should give out 21. But yeah, so you might think this is a really easy task. Like if you were programming this, usually this is a super easy task, but if we want to do it for a neural network, it's a slightly challenging task, because I think what we've got to do first is we can't just put the entire string in and hope that it will eventually just learn. It might, but that'll probably take a lot longer. So what I was thinking is, if we have a bunch of data, so first of all we're going to need the data, and the good news is we can generate this super easily using scripts. So we can actually generate like all possible combinations up to, let's say, 100. So that's good that we can get a lot of data easily. So let's put a tick there. Now the next thing we need is how we're going to train it. So what I'm thinking is we have we have one neural network which just detects the operators. So it just detects the operators which we're going to use. So we pass in a string and its only job is to detect the operators. And then we have another neural network which detects numbers, although I feel this is a bit like unnecessary, you know, because once you've split it, I guess yeah, okay, so I guess what we could do is we could have one neural network which just splits, like finds where the operator is located in a string, because obviously here they're all 2-digit numbers, but what if we put something like 45 times 2 in? It wouldn't really know where to split it. Like, as humans we know how to split it, it's just here, but a computer wouldn't know what index it's found at. So we're going to need to figure out a way of doing that. And finally we're going to need another neural network to actually complete the arithmetic. So what I mean by that is we just have to feed it loads of data, and eventually it just learned that 45 times 2 is in fact 90. So if you think about it, it's not really using its arithmetic powers, it's more using its arithmetic powers, a computer's transistors. It's not really using the computer's like ALU, arithmetic logic unit. It's actually just using the fact of the neural networks and the weights and biases. So that's why it's a bit more challenging for it to work out arithmetic, because yeah. So anyways, that will be second thing. Sorry, I waffled a bit too like that, but anyways, so that's what the second neural network is going to be about. And let's just call this for calculations. And yeah, so that is actually the overview of the project. So we've got our inputs, and these are our expected outputs. That should be able to enable a pretty easy cost function. Like for example, this one, cost function is just going to be ones and zeros, pretty simple. And for this one, I might have to come up with something a bit more sophisticated, because the output of this can really be any number. So I'm going to need to think of a way of condensing this. But yeah, it should be fine. And we're also going to have to think about a challenge of how do you pass inputs of varying sizes into a neural network, because these can be like, let's see, this is a string of 3 characters, this is a string of 4, it can go up, so might have to do some zero padding, things like that. But yeah, thanks for watching, and this was the overview of the neural network project, which I'm going to be starting soon. As I said before, I actually have no idea if this is going to work, but I guess we'll find out together. So bye.